Now let's begin with the implementation of neural networks. So first we will start by importing the necessary libraries and modules. Let's import NumPy as NP. As we are building neural network from scratch, we will not need many fancy libraries, just NumPy would be fine for us. And for performing the pre-processing steps, we will need some Scikit-Learn libraries, which are load iris for importing the data. We will be using iris dataset here from Scikit-Learn dot model selection. We will be importing train test split. So train test split will be used ahead for splitting the data into training and testing ratios so that a proper data can also be used for validation purposes. And for standard scalar, we will be using sklearn.preprocessing, and after that we will be importing standard scalar. And it is also good practice to always fix our seed so that our code and outputs are always reproducible. So let's run our code block or cell. After this, our job is to create or extract the data, or in simple words, load our data. So for that, we will convert this code cell into markdown cell. So for that, just press escape M and then enter. And after that, you can write markdown. Load data, shift enter. And after this, we will be initializing variable iris and loading our data into it. So load iris function is called here. For extracting the features, we will be using variable x. This variable will help us initialize our features like this, and y is our target variable. Like this, we have extracted our features. These are features. These are labels. After that, let's print the shape of data. So x shape is x dot shape and y shape y dot shape, a small y dot shape. So as you can see, there are 150 rows and 4 columns, and in target variable there is single column and 150 rows, and all of this data is in numbers, so we don't have to use encoding here. But in real world cases, when there is categorical data and string data, there we have to use appropriate methods for data processing. Let's continue with splitting the data into train and test. So for that, we will use xtrain, xtest, ytrain, and ytest equal to train test split x, then y, then our test size. Ideally we take test size equal to 20%, which is 0.2, and random state can be 2 or 42. It is common practice to take 2 or 42. And stratify y means that our output or our training data and testing data will contain equal ratios of the target variable. Like there won't be much of a disbalance between the training data and testing data. So yeah, like this we have splitted our data, and then we will be using scalar for standardizing our data. Using scalars are data which can be in the wide range of numbers can be converted into a specific range, which makes it beneficial for model to learn. Xtrain, which is scalar dot fit transform function, and we will be feeding Xtrain to it. Similar for Xtest. Since we have fitted our data, we don't have to refit it using the fit function. We can just transform. What This is a common mistake between beginners, that they tend to write fit transform again and again like this, which makes it meaningless. So once you fit your data, just keep it like that, and for the testing purposes, just transform it. After that, let's print the shapes. So extreme shape is extreme dot shape, and then y train shape will be y train dot shape. Yeah, everything seems correct. And yeah, you can see here, this is the train data, which is approximately 80%, or definitely 80% of the rows into consider that we have considered for training, and similar for the y train.